In terms of making sense out of a set of data, we can get quite a lot of sense out of the data simply by sorting it from smallest to largest. So I have a set of data here which I've randomly generated and then sorted from smallest to largest. So we can see that the minimum here is 18.8. So I'll just type in 18.8. If I go to the end of the worksheet by using Control End, I can see that the maximum is 90.4. There's maximum, 90.4. And from these two, I can work out what's called the range. The range is simply the maximum minus the minimum. So the spread in the data, in this set of data, is over 71.6%. Okay, so this is very useful. Something else we can get from a set of data is a set of statistics around the median and the interquartiles. I'll just put in a data range so that I can keep tabs on the data. So I have 99 data points. Okay, so these 99 data points are sorted from smallest to largest. So if we take the middle one of these, which would be the 50th, we can see that we have a value of 49.78. So this 50th value, there are 24 data points smaller than it, 49 data points smaller than it. So this middle value has 49 data points smaller than it, 49 data points larger than it. And we call this middle value the median, 49.8. This is a very useful way for defining where the middle of your data is. And we also have things called the interquartiles. In the same way that we got the median by finding the middle point in an ordered set of data, we can do the same thing on each half. So let's find the first interquartile. Let's call it Q1. So Q1 is halfway between the first data point and the median, so it should be the 25th data point, which will have 24 data points smaller than it, 24 data points larger than it up to the median. So that's 39.73. I'm going to do exactly the same thing on the other half of the data to produce a second interquartile, which should be at the 75th data point. And there it is, 60.9. So the interquartile range is equal to the upper interquartile minus the lower interquartile. And then the semi-interquartile range is half this. So this median is a quite often used method for finding the centre of a distribution. The interquartile range and the semi-interquartile range are used quite often to give you an indication of the spread of values in the data, as is the range, which is just the maximum minus the minimum. There are advantages and disadvantages to using the median as a measure of average and the semi-interquartiles. The advantage is that they are very robust to extreme values. So let's say we had a few values up around 100. They would tend to pull average values towards them, but they don't act so strongly on the median. One of the big disadvantages of the median and semi-interquartile range as a measure of average and of dispersion is the fact that they only work really well where you've got an odd number of points. So we've got 99 here. So we've got the median as the 50th point. It's got 49 data points smaller than it, 49 points larger than it. And same way for the interquartile. The first interquartile has 24 data points smaller than it, 24 data points larger than it. But if we have an even number in the data set, for example if you'd used 100 rather than 99 in our sample, then the median would lie somewhere between the 50th and the 51st data point. And there's no universally recognized algorithm for actually computing that. What that means is that, for example, if you used 3 different calculators for working out what the median was from a set of data, you could actually get 3 different answers. This is clearly not desirable. Given a set of data to a particular person, they should come up with the same answer every time. It shouldn't vary depending on which calculator they actually used.